Hello everyone and welcome to NPTEL online course on pharmacognosy and phytochemistry. In this week, we will learn about a very interesting set of compounds that are very lipophilic in nature, or what you can say oily in nature, and these compounds are lipids and volatile oils. So let's dwell into a week full of learning of this oleaginous compounds. Lipids, as the name indicate, are compounds which are lipophilic in nature. That means they are hydrophobic or soluble in organic solvents. Now plants and animals generate lipids. A good example of lipids is fatty acids. So plants and animals will generate fatty acids when they have to store energy in themselves. So lipids are primary metabolites which are generally used by plants and animals to store energy. Now if you go to see lipids, in them we can divide them as fixed oils, fats and waxes. Of this, fixed oils resembling to your cooking oil such as groundnut oils are generally liquids at room temperature. Of them, if you see fats, fats are liquids at room temperature but generally solidify if you drop down the temperature below 15 degrees Celsius. So below 15 degrees Celsius they are solids, whereas waxes remain solid till their congealing point, which are very low. Now these lipids can be obtained from plants or from animals by numerous techniques. The most easy one is expression. Imagine your groundnuts are crushed and expressed between two extruders to take out your groundnut oil, or the lipophilic substances of it can be dissolved in organic solvents such as petrol, hexane or chloroform to dissolve all the nonpolar compounds, and once they are taken out, this nonpolar solvents can be evaporated. On evaporation, the residual compounds that are left are all lipophilic compounds. So in lipophilic compounds, a simple compound we can discuss here is waxes. So what are waxes chemically? Waxes chemically are esters. Now if you see carefully, this is a fatty acid, and this fatty acid is esterified with a long chain alcohol. So waxes are nothing but esters of long chain fatty acids with long chain alcohols. So this makes them relatively high molecular weight and solids at room temperature. Whereas if you see your oils or fats, they are not simple esters but they are referred to as compounds called as triglycerides. Why? Because they form esters with not one hydroxys but they form esters with three hydroxys. So three such fatty acids will form esters with three alcohols to give you what is called as triglycerides. The reason why they are called as triglyceride is, if you see this moiety which is highlighted in blue, this is your glycerol. So with every hydroxy of glycerol conjugating and forming an ester linkage with a fatty acid, sometimes this fatty acids may be similar, sometimes this fatty acids may be dissimilar. So take a molecule of glycerol, take three fatty acids, when they conjugate with each other, they are called as triglycerides. So if you see lipids, where it comes to your fixed oils or fats, they are generally triglycerides, whereas if you see your waxes, they are generally monoester derivatives. Now, a little different from that is volatile oils. Volatile oils have absolutely nothing to do with fatty acids. In fact, volatile oils are not primary metabolites. That means they are not generated by the plants to store energy. In fact, they are generated by plants and animals for attracting insects or repelling insects. So if you take a whiff of rose, you get a beautiful aroma. That aroma compound serves the purpose to attract insects so that it can pollinate. On the other hand, there are certain plants, take for example eucalyptus. In some cases the purpose of that is to repel insects, or in some cases the plants also secrete this aroma chemicals to communicate with each other, and there's a huge science behind it. The science is called as allelopathy. So mutually they communicate with each other, they show each other their strength, and they show each other they are existing. So this volatile or essential oils which have a nice aroma are produced as secondary metabolites in plant. Now knowing that they are volatile, they are generally not expressed or pressed, they are generally distilled. They are volatile, they have a low boiling point. So if you distill, they easily get collected as distillate and you can get your pure aroma chemicals being distilled out. So few examples of volatile oils are those that belong to the class of terpenes. Here I have two examples. If you see this, the first one is limonin, and this occurs in your orange peel. And the second molecule, if you can see, it's almost similar, but there is an adduct being formed out here. So more 5 carbons being added to it, and this compound is called as bisabolin. So this occurs in your Gingiberae family members, so you will see them occurring in your ginger and so on. The next class of compounds which are there in your essential oils are phenylpropanoids. So phenylpropanoids are known for their phenyl ring, and in addition to that phenyl ring you will have 1, 2, 3 carbons, often referred to as propanes. So the first structure here is the structure of anethol, which is present in your fennel. In your restaurants, when you go post your meals, you've been served buddy soft or fennel fruits. These fruits have a nice flavor as well as a good aromatic taste. This is attributed to anethol. Now one more compound here is your eugenol. This occurs in your clove, is also an example of phenyl propane derivative. So your volatile oil, rather than containing a long chain fatty acids, contain beautifully small fragrant molecules which are low molecular weight belonging to the terpenes and the phenylpropanoid class. Now if I have to differentiate between lipids and volatile oil, the first point is lipids are primary metabolites. The plants, animals will produce them for the reason of storing energy. They are the energy storage molecules, whereas if you see essential oils or volatile oils, they are your secondary metabolites. They have more advanced function like your pollination or defensive functions, or sometimes some aroma chemicals are potent enough to kill plants in the vicinity as well. Now if I talk about lipids, they are generally esters and esters of fatty acids. If you say your fixed oils, or if you say your fats, they are esters of glycerol, whereas if you say your waxes are esters of monohydric alcohols. Whereas if you see your volatile oils, we just saw they are derivatives of terpenes or phenylpropanoids. Now lipids or oils or fixed oils, if you see groundnut oil, if you see your linseed oil, if you see your mustard oil, this fixed oils are present in plants to a very large extent, especially if you see the seeds oil. Seeds are laden with it, so just merely pressing it, you can get the oil out of it. Whereas volatile oil are present in very lesser percentage, in some cases it may be just between 1 to 5%, and as a result when you just press it, it might be difficult to procure essential oils. So lipids can be easily brought in or extracted by expression. Volatile oils, you will have to distill the plant part to get the essence out of that. Now coming to the next point, needless to say lipids, because they are high molecular weight compounds and esters of big fatty acids with glycerol, they have a very large molecular weight and a very high boiling point, whereas your essential oils have a very low boiling point and can be distilled out very easily. Lipids can be further divided into fixed oils, which are liquid at room temperature, and triglycerides, fats, which are solid below 15.5 degrees Celsius but still triglycerides, and waxes, which are esters of monohydric alcohols. Whereas essential oils you can categorize into two categories. One is called as eleoptenes. Now these are compounds which are liquids at room temperature. Take for example your rose oil, it's liquid, whereas stereoptenes are derivatives which are solid at room temperature. If I give you an example of camphor or menthol or thymol, these are essential but at the same time they are solids at room temperature. So depending upon their physical state, you can classify essential oils or volatile oil as eleoptene and stereoptene derivatives. So let us understand now the differences between your lipids, that is your fixed oil, fats and waxes. As we discussed, if you see your compounds such as your groundnut oil, which are liquids at room temperature, they are called as fixed oils. Now substances which generally solidify below a temperature of 16.5 degrees Celsius and are triglycerides in nature are referred to as fats, whereas waxes are esters of monohydric alcohols and are solids at room temperature. A good example of that would be your beeswax. Now if you see esters of fatty acids, in nature there are numerous fatty acids which are present ranging from different carbon length. This carbon can be as small as C3, C4, propionic butyric acid, and you can go on and adding more carbons to it. So if you see a range like C12, C14, C16, C18, we refer to as your myristic, lauric, capric or even your stearic acids. They form esters with glycerol to give you what are called as fixed oils. The degree of saturation determines their solid nature. So if you have more unsaturation, they will form liquid substances or liquid oils. The moment there are saturated fatty acids, especially saturated long chain fatty acids which are forming esters with glycerol, in that case they form solid compounds below 16.5 degrees Celsius and they are referred to as fats. I'll exemplify this with a simple example. If you heard of vegetable ghee or dalda, that's basically a fixed oil, and fixed oils are liquids at room temperature and they contain number of unsaturated fatty acids. Suppose if you hydrogenate it, what is going to happen on hydrogenation is all those double bonds are going to get reduced and you're going to get more saturated compounds. This saturated compounds create solids, or this saturated compounds create more ordered structure and become solid and therefore are referred to as fats. So your vegetable ghee or dalda can be referred to as hydrogenated fixed oils or simple fats, which are solids at a temperature below 16.5 degrees Celsius. On the other side, your waxes, because they contain a large carbon fatty acid, say for example melicic acid or C30, C32 fatty acids. Now here the carbon length is relatively large and there is a huge ordered structure, and as a result even at room temperature these compounds remain solids. So they contain a higher ratio of high molecular weight saturated fatty acids compared to your fixed oils and fats. A good example of this, that is your fixed oil, is groundnut oil. A good example of fats is your dalda or a vegetable ghee, and a good example of waxes is your beeswax. Now if you see fixed oils, imagine groundnut oil, sunflower oil or most of your cooking oil. They are thick, they are very viscous, slightly yellow to green color. Now the interesting part is if you see fatty acids or glycerides of fatty acids, they are colorless. This yellow color of the oil actually comes from the pigments which are present in plant. So suppose if you are extracting olive oil, olives naturally are green in color. So if you press those olive fruits, you will get a green color oil because the chlorophyll are lipophilic pigments and they will get dissolved. Similarly, if you think about your coconut, or if you think about your coconut oil do not have any pigments in them, and as a result your coconut oil comes in very clear. Whereas in some cases in seed oil, you will see the pigments, especially of their hulls coming in, and that contributes to little yellowness. Not only are they colored because of these pigments, in some cases the compounds which are present, that is the lipophilic compounds which are present, also impart a characteristic odor to them. Now fixed oils, because they are not volatile, cannot be distilled, but you can easily convert them into soap. Now what happens is a classical saponification reaction. So if I am talking about a triglyceride, on hydrolysis it will give me back my glycerol, plus it will give me back my fatty acids. Now this hydrolysis is generally done in presence of a base. So what is going to happen here is this hydroxy is generally replaced by a alkali. So you get sodium salt of fatty acids, which we refer to as soaps. In the process, this hydroxys also get converted into their corresponding sodium salts and become more water soluble. So you get soaps, and fixed oils can easily saponify. In fact, most of your soaps that you use are sodium salts of fatty acids. Now one more thing is, if those fatty acids are unsaturated, that is if they contain double bond, what is going to happen is they absorb or react with oxygen which is present in the air. They form what are called as initially peroxides, and these peroxides later on cleave to give you aldehyde like derivatives. So simple example of a cleavage at 12 will give you a hexenal and other degradation products. So if you see that certain dry fruits, especially your cashew nuts, initially they'll have a good flavor, but later on they turn rancid. Rancid is nothing but it's a odor and it's a flavor which is developed due to presence of aldehydes in your drug. That can be your oils, that can be your fixed oils, or that can be your oil containing substances such as dry fruits. Now if I take oil or cooking oil, it's not going to be soluble in water. So they are highly lipophilic, they are insoluble in water, they are insoluble in alcohol, bearing one, which is your castor oil, which is slightly soluble in alcohol, but they are happily or readily soluble in organic solvents. These are your chloroform, ether or your diethyl ether, petroleum ether and benzene. Now depending upon what makes the triglyceride, you can have saturated, monounsaturated, polyunsaturated fatty acids or cyclic unsaturated fatty acids. So if you see monounsaturated fatty acids, you must have heard of this name called as MUFA. Monounsaturated fatty acids are commonly referred to as MUFA, whereas polyunsaturated fatty acids are referred to as PUFA. PUFAs are generally considered as good for your health. A good example of PUFAs are your omega-3 fatty acids. Now omega-3 fatty acids derive their name from the omega unsaturation. So if you see IUPAC nomenclature, we generally number it from the first carbon. Now in Greek you call it as your alpha or A. Now let's say the terminal or the last one, denoted by a Greek alphabet omega. So if you start, this is called as your omega 1, this is called as omega 2 and this is called as omega 3. The fatty acid derivatives in which the omega 3 is unsaturated are called as omega 3 fatty acids. Now they are a kind of essential for us because many of them our body is unable to produce. So we have to exclusively rely on external sources for their sourcing. Now why do we have to rely on them? Because they make a essential component in our body, such as your cellular membrane, such as your neuronal sheath. So if you see your health supplements, you must have heard of or you must have read EPA, DHA or ALA. So what is this? This is your ALA is your alpha linoleic acid, which is a 18 carbon containing omega 3 fatty acids. Eicosapentaenoic acid is a 20 carbon containing pentene because there are 5 double bonds. So eicosa is your 20 C20 containing 5 double bonds, and the first one being at omega 3. Apart from that, there is also one more important essential fatty acid, and that is your docosahexaenoic acid. This is a C22 and it contains 6 unsaturation. That is why it is hexenoic acid, and it is also an omega 3. So these 3 fatty acids are considered to be essential for us and they play a vital role in our body. Apart from that, when your oils are extracted from the plants, they also dissolve numerous lipophilic ingredients. Now these lipophilic ingredients include vitamins, especially the oil soluble vitamins, sterols like your cholesterol, cytosterols or plant sterols, antioxidant compounds such as carotenes, phospholipids and pigments such as chlorophyll. Now as they are being produced, they also deteriorate and gives aldehydes, ketones and other derivatives. Now this aldehydes, ketones and other derivatives which also make their way into the oil are responsible for the flavor as well as odor. So if you see fats, fat contains more percentage of saturated fatty acids as compared to your fixed oils. Now all of these ingredients you can use as emollients. Emollients are something which can prevent your moisture from evaporating. So especially during the cold dry season, you will see your skin turning very harsh or dry or very rough. In that case, if you want to prevent the evaporation of oil, you apply a oily layer. We apply creams, and these are referred to as emollients and often in some cases demulcents. Now a good source of essential fatty acids, we also have your linseed, which gives your linoleic acid, linolenic acid and arachidonic acid. So here are few. Apart from that, we can have oils coming from your marine sources as well. Now chemical test, you can identify your fixed oils by using sodium hydroxide. Now this is a simple saponification test. So if you take your oil and saponify with sodium hydroxide, you know you are bound to get a soap. Now this soap is going to be water soluble. So this, when you dissolve copper sulfate to it, which is nicely water soluble blue salt, you will see a homogeneous solution. Whereas if it is not a fixed oil, if it is something like a hydrocarbon or if it is something like a paraffin, it will not saponify, and as a result your copper sulfate will form a distinct layer and it will not dissolve. Another way to check if your compound is a triglyceride is by converting that glycerol into aldehyde derivatives or even ketone derivatives. For that, what you have to do is take some oil, about 5 drops, add a pinch of sodium hydrogen sulfate and heat it. The moment you heat it, it gets converted into acetol or sometimes your 3-hydroxypropanol, which further is converted into acrolein. The typical acrolein or glycerine odor is, if you get, it is saying that it contains your glycerol and therefore it's a triglyceride. Now fixed oils can be classified into, depending upon their nature, especially your oils and fats are divided into drying, semi-drying and non-drying. Now if you say fats, they are going to be solid. So examples of that is your cocoa butter, kokum butter, your nutmeg butter, or your coconut oil. So they are generally solids at considered solid as room temperature. Non-drying oils are the oils which will not change in their viscosity. Now there is an important reason for it. Now whenever the oils have unsaturation, this unsaturation causes them to oxidize and polymerize. The moment they oxidize and polymerize, they form film. So on drying, when they form film, they are called as drying oils. The good example of drying oils are linseed oil, hemp oil, poppy seed oil, or your walnut oil. Semi-drying, they have unsaturated compounds but little less. So they don't form a very strong film and do not dry out quickly. Example of semi-drying are your castor oil, mustard oil, sesame oil, or even your rapeseed oil or cottonseed oil. Non-drying oil, they contain mostly your saturated compounds but small chain, and as a result they don't resinify or they don't form a film. So examples of non-drying ones are your peanut, almond, croton, or even your ras bran oil. Now if you see animal sources, you can obtain oils and fats from animals also. This include your marine animals such as your fish. So from fish, if you take the bones, you can get your bone tallows, which are fats, or if you take your liver, your cod liver or shark liver oil, which is obtained by heating the livers of cod and shark. You can get your whale oil from the skin and parts of whale. Apart from that, there are certain terrestrial animals which are used for that. So if you see your lard or mutton, you heat it, you get a good amount of fats which solidify at room temperature, and also some oils such as your lard oil. So once the lard is solidified, you get a liquid around it. That's referred to as lard oil. And there's also an animal which gives you a neat's foot oil. So these are two sources or animal sources of your fats and oils. Now comparing or coming to waxes, waxes as we discussed are made up of monohydric alcohols conjugated with one fatty acid. They are unctuous fused substances with a waxy luster. They are high molecular weight, made up of monohydric alcohols. Generally their constituent is a fatty alcohol or sometimes sterol such as cholesterol. Fatty acid alcohol can be your cetyl alcohol or malicyl alcohol. Fats are completely insoluble in water. They are lighter, less dense, so they float, and they are very resistant to saponification. Some example of waxes include carnauba wax, Japan wax, or bayberry wax. And from animal, the waxes that you get are your spermaceti, beeswax, or even your wool fat. Now coming to volatile oil, they are very odorous principles. They evaporate when exposed to air or even at room temperatures. That's where you have your perfumes. Because they have a nice aroma, they are called as essential oils because they represent essences or odorous principles. They are made up of terpene derivatives or phenyl derivatives. They may be their oxygenated derivatives present in various parts of plants. Unlike your fixed oils and fats which rancidify, this actually polymerize to form resinous derivatives. An example of volatile oil contains drugs are your eucalyptus oil, that is your nilgiri, and your rose oil. So here are a few textbook references to this part of the lipids, and thank you everyone for your patient listening.